So when you're doing this trick, typically called Feynman's integration trick, even though it's not due to Feynman, but when you're doing this trick, how do you pick the parameter t? How do you pick where to put it? And that is exactly the reason why this trick is usually not taught in calculus classes, because it's a nightmare to teach. There is no rhyme or reason. You really have to be very creative about where to put the value of the parameter t. So there is some art or creativity or like really thinking hard about where to place a parameter t so that the trick works. You have an integral that you want to compute, you introduce the parameter, and you have to put the parameter somehow so that there is a value of the parameter that gives you the original integral. There is a value of the parameter that gives you a very easy to compute integral. And when you take the derivative inside, you get some other function g prime of t that has to be between those two values of parameters we found. That integral is very easy, much easier than the original integral. And the problem is that there are a lot of choices of parameters where the trick does not work at all, where you don't find something that is easy computable down there, or this integral is just as difficult or more difficult than the original integral. So there's lots of choices that are bad choices. So let me give you some examples of parameters that work. So for this integral, which appeared in the original video about this trick, instead of the exponent 2, we put a parameter t. For this integral, we're going to put the parameter right there, so we get this parametric integral. For this integral here, which is similar to that one, you would think maybe t times this would work, but no, that's not the parameter that works. The parameter that works is t times 1 plus x squared. For the integral of sine of x over x, the parameter is actually in an exponential factor. For the integral of x over tangent of x, one choice of the parameter that works actually involves arctangent of t times tangent of x. Notice that when t equals 1, the numerator is x, so I get the original integral for t equals 1. How about the integral of e to the cosine x, cosine of sine of x? You have to put the parameter in two places, e to the t times cosine x, cosine of t times sine of x. That's a choice that helps. And if you want to see a lot of other examples of where to place the parameter, there is a question on MathStackExchange exactly giving you examples with a long list of examples that are clickable. And if you click on them, it takes you to some other MathStackExchange page where they show you how to do it.